This lecture is about software maintenance. Software maintenance is modifying a software system or component after delivery to correct faults, improve performance, add new capabilities, or adapt to a changed environment. Software maintenance consumes 60 to 80% of the total lifecycle cost. 75% or more of the costs are due to enhancements. Many decades old legacy systems are still in operation today. These systems cannot be retired because of the high cost of replacing them. Also, there's no guarantee that the new system would adequately replace the legacy system. Legacy systems have embedded collective knowledge, experience, and intelligence of many software engineers and domain experts. If replacing these systems were an option, it could be too costly. After these systems are released, there's a long period of modifications to correct errors and enhance the capabilities, adapt to new operating platforms, and improve system structure. This process is called software maintenance. According to IEEE, software maintenance is modifying a software system or component after delivery to correct faults, improve performance, add new capabilities, or adapt to a changed environment. After a system is released, a number of factors can mandate software change. Some of these are bug fixes. Although the software was tested, some bugs may occur during the operational phase. These require bug removal and regression testing to ensure that the fixed software passes tests that were performed on the previous system. 2. Changes in operating environment. Changes in hardware, software system configuration, or platform may require software modification. 3. Changes to government policies and regulations. Changes to government regulations and policies may require software system changes to comply with the new regulations or policies. 4. Changes to business procedures. Business procedures are automated by software systems. When business operations change, software systems must change accordingly. 5. Changes to prevent future problems. When future problems are expected, software systems changes can take place to prevent future problems. For example, redesign and re-implement a component to improve its reliability. Lehman and Belady conducted studies on systems evolution. The results of these studies were the Lehman laws of system evolution. These laws are specified for the E-type systems. These systems cannot be completely defined. E-type systems development is a wicked problem. On the other hand, the S-type systems can be completely specified. Their development is not a wicked problem. Examples of S-type systems are mathematical software and chess playing software. The 8 Lehman laws are: 1. Law of continuing change. After a system is released, changes to the system are required, and these changes continue until the system is replaced. 2. Law of increasing entropy or complexity. As changes are made, the structure of the software system deteriorates. Changes introduce errors that require more changes. Changes also introduce conditional statements to handle erroneous situations or check for invocation of new features. These increase the complexity of the system and coupling between the components. The result is that the system becomes more difficult to understand and maintain. Restructuring or reengineering is required to improve the structure of the system and to reduce the maintenance costs. 3. Law of self-regulation. The system evolution process is self-regulating. Many system attributes, such as maintainability, the release interval, the error rate, appear to be stochastic from release to release. However, long-term trends exhibit observable regularities. This is universal. This law, due to the eighth law, that is, the law of feedback systems. The regularity is a result of feedback loops and interaction of factors that cancel each other as well as enhance each other during a long period of maintenance activities. This law is also a generalization of the next three laws: the law of conservation of organizational stability, the law of conservation of familiarity, and the law of continuing growth. The law of conservation of organizational stability. The maintenance process of an E-type system tends to exhibit a constant average work rate over the system's lifetime. The 5. Law of conservation of familiarity. The average incremental growth of the system remains constant during the system's lifetime. 6. Law of continuing growth. E-type systems must continue in functional growth to satisfy its users. 7. Law of declining quality. The quality of E-type systems will appear to be declining unless they are vigorously adapted to the changes in the operating environment. 8. Law of feedback systems. The evolution process consists of multi-level, multi-loop, and multi-agent feedback systems that play a role in all the laws. That is, the other laws are due to the feedback behavior. Liebman's law of increasing entropy implies that the system will be replaced because the cost to maintain it would exceed the cost of building a new system. This is true for some types of systems, for instance, operating systems. However, many organizations find that replacing legacy application systems is not an option because numerous business processes and business rules have been implemented in the legacy system during a prolonged maintenance system. Additionally, millions of records are stored in databases. There is inadequate documentation, and the complexity of the system is such that no one really knows what was implemented or how to port the data records. Therefore, many Legacy systems are still in use and companies spend millions of dollars maintaining them each year. The IEEE categorizes software maintenance into four types. 1. Corrective maintenance. Reactive modification of a software product performed after delivery to correct discovered faults. 2. Adaptive maintenance. Modification of a software product performed after delivery to keep a computer program usable in a changed or changing environment. 3. Perfective maintenance. Modification of a software product performed after delivery to improve performance or maintainability. 4. Emergency maintenance. Scheduled corrective maintenance performed to keep a system operational. On the other hand, is a planned maintenance activity. Most maintenance costs are due to enhancements made to a system. Some authors explicitly refer to this type of maintenance as enhancement maintenance. Software maintenance continues until the system retires. Software maintenance is a process like software development. Many maintenance process models have been proposed. Regardless of which process model is used, software maintenance performs a set of basic activities. These activities include 1. Program understanding. Maintenance software engineers must know the software before he or she can change it, therefore program understanding is required. 2. Change identification and analysis. This activity identifies the needed changes, analyzes their impact, estimates the effort, and assesses the change risk. 3. Configuration change control. Software engineers who maintain the affected components must be involved in the decision-making process. This activity requires the maintenance team to prepare an engineering change proposal. It serves to inform the relevant stakeholders of the change and solicits their feedback. A board of members review the proposal. The board may approve or disapprove the changes for the required proposal or require the proposal be revised to address their concerns. 4. Change implementation, testing, and delivery. The approved changes are made into an existing system. This involves recovery of the design from implementation and modifying the design to satisfy the changed requirements. The system is modified to incorporate the changes. Integration testing, acceptance testing, system testing are performed to ensure that the system was correctly modified. The system is then delivered to its operating environment. During its operation, data are collected and used to compute the metrics such as performance, response time, number of reboots, and so on. Defects are recorded. These are the input to the next maintenance cycle.